Today what we will be doing, we'll be looking at a number of key topics that we expect to see in the CSEC examination, beginning with number theory and operations on sets of numbers. So we'll be focusing on fractions, decimals, approximations, truncating to a number of decimal places, significant figures, and standard forms. So of course we'll be looking at questions to highlight all that I've just mentioned. So let's get into it. So today we're going to start with fractions. So we have here 1, 3 and 3/8 divided by 5 over 12 plus a third. Of course, to treat with this, we are going to apply the rules of BODMAS. So BODMAS, some of us say PEMDAS. First, if it's BODMAS, B stands for brackets, O means order, D means division, M is multiplication, A addition, S subtraction. If it's PEMDAS, P stands for parentheses, E represents exponents, M is multiplication, D division, A addition, S subtraction. So let's look at it. So we're going to start off with our brackets or parentheses. So we're going to work what's in brackets. So this will be 5 over 12 plus a third. If we're adding fractions, the first thing we do is find the LCM. The LCM is 12. So 12 into 12 is 1. 1 by 5 gives us 5 plus 3 into 12 will be 4. 1 by 4 will give us 4. And we know 5 plus 4 will give us 9 all over 12. Which we can simplify. We can say 3 can go into 9, 3. 3 can go into 12, 4. But what we want to do is ensure that we maintain the order of the question. So this will be 3 and 3/8 divided by, maintain that order, the result of what we got in brackets, which is 3/4. Of course, 3 and 3/8 is a mixed number, so we have to convert this mixed number to an improper fraction. So you know 8 by 3 is 24, and 24 plus 3 will give us 27 all over 8, divided by 3 all over 4. And in dividing two fractions, we always leave the first fraction as is. So this is 27 over 8. We change our division operation into a multiplication operation, and we invert the second to get 4 over 3. Of course, when we are multiplying fractions, we look to see what factors are common to both numerator and denominator. So we can clearly see 4 into 4 is 1, 4 into 8 is 2, 3 into 3 is 1, 3 into 27 will give us 9. So we're left here with 9 all over 2, and this improper fraction we can convert back to a mix. So that is 4 by 2 will give us 8, and 8 from 9 will give us a remainder of 1. So we have 4.5. Let's look at the second question. So again, using a calculator, otherwise find the exact value. Of course, we're going to apply our rules of BODMAS or PEMDAS to help us to solve what we have here. So let's get into it. So we have here, so again, looking at the order of our operations, we have 7 over 8 plus 1 over 6 divided by 2 all over 9. So what are we going to do? From our rules of BODMAS or PEMDAS, division comes before addition. So we're going to divide these two fractions. So this will be 1/6 divided by 2 over 9. So in dividing two fractions, what do? We leave the first fraction as is. So this is 1/6. We change our division operation into a multiplication, and then we invert the second to become 9 all over 2. So what are we going to do here? We are going to, of course, look to see what factors are common to both numerator and denominator. So I can say 3 into 6 is 2, 3 into 9 is 3. There's nothing else common to both numerator and denominator. So I'll multiply 1 by 3 is 3, 2 by 2 is 4. But of course, we want to maintain the order of our question. So this will be 7 over 8, which will be written first, plus the result of dividing 1/6 by 2 over 9, and we are going to get here, of course, the result of that is 3/4. And we have to add these two fractions. So to add these two fractions or subtract, once we're adding or subtracting, we must find the LCM. The LCM of 8 and 4 will be 8. So I divide 8 into 8 is 1. 1 by 7 is 7. Plus 4 divided into 8 is 2. 2 by 3 will give us 6. And of course, 7 plus 6 will give us 13 all over 8. And we can convert this in proper fraction, and I will advise convert it back to a mix. So when we divide 8 into 13, we're going to get 1, remainder 5. So we get 1 and 5/8. Let's look at the next. We have here 2 1/4 minus 1 3/5 divided by 3. So let's look at this question. So to treat with this, what are we going to do? This is 2 1/4 minus 1 3/5 all over 3. So again, to treat with this, we're going to work out what we have in our numerator. So we need to get a single fraction in our numerator. We also need a single fraction in our denominator, which we already have. And of course, we're going to divide those two fractions to get our final result. So to work what we have in our numerator, first, let's ensure we convert all mixed numbers to improper fractions. So 4 by 2 is 8, plus 1 will give us 9 over 4. Subtract 5 by 1 is 5, plus 3 will give us 8 all over 5, all over 3. So we are going to work what we have in our numerator first. So this is 9 over 4 minus 8 over 5. So 9 over 4 minus 8 all over 5. When we are subtracting fractions or adding fractions, the first thing we do is find the LCM. The LCM of 4 and 5 will be 20. So we divide 4 into 20, which is 5. We multiply 5 by 9, which is 45. Subtract 5 into 20 is 4. And we multiply 4 by 8, which is 32. And of course, we subtract 32 from 45, which will give us 13 all over 20. So in our numerator, we're going to rewrite this as 13 all over 20 all over 3, which can be rewritten as 13 all over 20. Your vinculum becomes a division operation. And 3, we're going to write 3 as 3 over 1. But of course, when we divide in fractions, what we do? We always leave the first as is. We change that division operation into a multiplication operation, and then we invert the second fraction to become 1 over 3. And when we're multiplying fractions, we look to see what factors are common to both numerator and denominator. So if you look, there are no factors common diagonally or vertically. So what we do here, we multiply what we have in our numerator. 13 by 1 is 13. And we multiply what we have in our denominator. 20 by 3 will give us 60. So the answer to this should be 13 all over 60. Let's look at the next question. Right, so we're looking here at rounding numbers to a number of significant figures, and of course testing your knowledge of adding, subtracting decimal numbers when necessary, multiplying, dividing decimal numbers when necessary. So let's get into it. So we're looking at by rounding each number in the expression below to one significant figure, estimate the value of. So we have the square root of 108 over 19.72 plus 5.296. So by rounding each number, so we have to round each number, correct, to one significant figure. So to do so, what are the steps? So if you have to round a number, correct a number of significant figures, and in this case, one significant figure, we have 108. If we have to round 108 to one significant figure, for significant figures, we always count, and we are counting from the first non-zero digit from left to right. Our first non-zero digit from left to right is 1. So if it's one significant figure, I count one. This is my first or one significant position or figure. So to approximate this, I must look at the number immediately after. If the number immediately after is 5 or more than 5, then I will add 1 to the number I have underlined, which is my one significant position, one significant figure. If the number after is less than 5, then my number underlined remains as is. So if you look, immediately after 1, we have 0, which is less than 5. So this 1 here stays as is. But what we always do for whole numbers, we always replace the remaining digits of the whole numbers with zeros. So therefore, we're not going to write 108, but we're going to write 100. 100. All remaining digits of the whole number must be replaced with 0. So the square root of 108 now becomes the square root of 100. So that's 108 rounded to one significant figure. So now let's look at 19.72. Let's round this to one significant figure. So again, what do? We count from the first non-zero digit from left to right. So we're looking at one significant figure. So that's my first significant position or figure. I must look at the number immediately after, which is 9. Once that number is 5 or more than 5, I add 1 to my number, which is underlined 1. So that 1 becomes 2. And because 19 is a whole number, the remaining digit of the whole number must be replaced with 0. So this becomes 20. And what we do, any digits that exist after the point, we ignore them. So you're not going to put back 0.72, you're not going to put 0.00, you ignore them. So this here rounded to one significant figure will be 20. So we have 20 plus we have 5.296, and we want to round that to one significant figure. So again, we count from the first non-zero digit from left to right. So we're counting. So first non-zero digit will be 5. That's one significant figure. I must look at the number immediately after, which is 2. It's less than 5, so my 5 stays as is. And my 0.296 I ignore. And don't replace them with zeros. Just remain as 5. So all my numbers have been rounded or approximated to one significant figure. And now I can simplify. So the square root of 100 is 10. This is 20 plus 5, which is 25. And I can simplify this now. 5 into 10 is 2, and 5 into 25 is 5. So we have 2/5. Let's look at the next. We have here, using a calculator, otherwise, evaluate each of the following given your answers correct to 2 decimal places. So we want to use our calculator to help us to determine such. So we have here 73.18 minus 5.23 multiplied by 9.34. So of course this requires us to use our calculator. So let me get my calculator quickly. I will do with my calculator. Nice. So to treat with this, what are we going to do? Again, from our rules of BODMAS or PEMDAS, we will carry out our operation based on the rules. So we are going with BODMAS. We know that multiplication comes before subtraction. So we are going to multiply first. So we're going to multiply those 2 decimal numbers, 5.23 multiplied by 9.34. And of course, as mentioned in the question, using a calculator otherwise. So maintaining the order, this will be 73.18. So 73.18. Subtract, let's multiply 5.23 multiplied by 9.34. And we're going to get here, and we put down all the digits we see on our calculator. This is 48.8482. So 48.8482. So let me double check that. 5.23 multiplied by 9.34. Yeah, 48.8482. And now let us subtract those two decimal numbers. This is 73.18. Subtract 48.8482. And we're going to get here 24.3318. But what they want us to do, they want us to now, round this answer, approximate this answer to two decimal places. So for decimal places, again, we're going to count. We're not moving that point. Please don't move that point. Students love to move the point. We're not moving the point. We are counting from the first digit after the decimal point. So we're counting 1, 2. So the number of underlined there will be my second decimal place or position. But to approximate that, I must look at the number immediately after. The number immediately after is 5 or more than 5. You add 1 to the number that is underlined. If the number immediately after is less than 5, the number underlying 3 stays as is. So the number after my 3 is what? 1. It's less than 5. So this 3 here stays as is. So I can write or approximate my answer to two decimal places as 24.33. And I ignore all digits that exist after. I do not put back zeros. I do not put zeros, nor do I put back 1 or 8. I ignore them. So let's look at part 2. Part 2, we have 3.1 squared all over 6.17 plus 1.12. Yeah? So from our rules of PEMDAS, E stands for exponents, right? Or index or powers. So what we're going to do is treat with 3.1 squared first, which is the same as 3.1 multiplied by 3.1 over 6.17 plus 1.12. So let's look at what is 3.1 multiplied by 3.1. So 3.1 multiplied by 3.1, and again we have access to our calculator, so we can use the calculator to help us. So this will be 9.61 divided by 6.17 plus 1.12. So again, what we're going to do, we know that division comes before addition. So let's divide. This vernacular here means division. So this is 9.61 divided by 6.17, which will give us, this will be 1.5575. And they want us to approximate our answer to two decimal places. So you can go up to the third position after the point, or even the fourth position after the point, plus 1.12. So if it's to two decimal places, I will suggest that you go to the third position after the decimal point. So we leave it as 1.557, seeing that we have to approximate to two decimal places. So I'll go to the third position after the point. And now let's add those two decimal numbers. This will be 1.557 plus 1.12, which will give me 2.677. And now I can approximate or truncate that number to two decimal places. So what do we do? For decimal places, we focus on the digits after the decimal point. And we are counting the positions. Do not move the points. We count 1, 2. That is my second decimal position or place. I look at the number immediately after, which is what? 7. It's more than 5. It's 5 or more. So I add 1 to my 7, which is underlined, to become 8. So this here will be 2.68 to two decimal places. Let's move on to the next. They want us to express this number 3.8 by 10 to the power of 2 plus 1.7 by 10 to the power of 3, given your answer in standard form. So let's represent that result of the sum of those two numbers in standard form. So we have here 3.8 by 10 to the power of 2 plus 1.7 by 10 to the power of 3. Given your answer in standard form, of course, you must first recognize and understand what is represented in number in standard form. A number in standard form is always of the form a by 10 to the power of n. A simply means that your number must lie between, it must be more than or equal to 1 but less than 10. So it must be more than or equal to 1 but it must be less than 10. So more than or equal to 1 but less than 10. Good? 10 is always fixed, so 10 doesn't change, and n is your power or index. Of course, that power is a positive power, so n is positive when the decimal point moves to the left, and n, your power, is negative when your decimal point moves to the right. So the trick with this here, we can simply multiply 3.8 by 10 to the power of 2, which is the same as 3.8 by 100, plus we can multiply 1.7 by 10 to the power of 3, which is 1.7 by 1000. So 3.8 by 100 means we're going to move this decimal point 2 places to the right. So if I move this 2 places to the right, then 3.8 becomes 380. Moving my point 2 places to the right. If I have to multiply by 1000, I have to move this decimal point 3 places to the right. So if I move it 3 places to the right, so I'll have my addition sign, and 3 places to the right, this becomes 1700. If I move it 3 places to the right, okay? So what I'm going to do here now is to add those two numbers, and when I add those two numbers, then I'm going to express that result in standard form. So this is 380 plus 1700, which will give us 2080. So we have 2080, and now let's represent 2080 in this form, known as standard form, right? So to do so, I must ensure that this number A lies between 1 and 10. So this presently doesn't lie between 1 and 10. This is 2080. So to make this number lie between 1 and 10, a decimal point, which is understood after 0, must move, or it must occur between my 2 and 0. Yes, it must occur between my 2 and 0 in order for this number to lie between 1 and 10. So in order for that to happen, it means that this point must move 1, 2, 3 places to the left. So this becomes 2.080, which now represents A and now lies within 1 to 10, multiplied by 10, which is always fixed, so it's always 10, and n is your power, and your power is dependent upon how many places your point moves and the direction. So my point move 1, 2, 3 places to the left, and remember, when your decimal point moves to the left, the power is a positive. So this will be positive 3. So your result for the question shown in standard form is what we have here.